the writing prompts, the next thing was the group whiteboards. So asking them to compare friction, think of times when friction exists for something that is moving and times when friction exists for something that is not moving. And I would say right off the bat, there was a nice list of friction for things that are moving, but they did not know what to do for friction when things aren't moving.
My kids were really
right. Yeah, just go ahead.
My kids were really confused when I said stationary objects. Like, then there's no friction.
Right.
So you had to really think about
Not moving,
that.
no friction.
So I put my phone on my desk and tilted my desk over, and since there's an OtterBox nice rubber seal to it, it wasn't going anywhere, even at a steep incline. So I was like, well, why isn't it falling off the desk? And then started getting them to think about that, well, wait, there's friction holding it on the desk. And so they started coming up with ideas at that point.
I guess you could even put up, now that you said that, you could put up a different object that does slide off. So
Yeah.
they realize
Yes.
at that angle, things can fall, but this doesn't, so something different
It's
must
actually a
exist
really
here.
good idea because
Yeah.
it's easy to do, it's quick, and it's so visual that
Yeah.
it's like, what's the diff?
Yeah,
And
that's
you can get it go at a really steep incline, too.
Yeah.
right.
So it's impressive.
And then, what did you say before? I thought you said,
Well, we were talking about how when we first did the whiteboards and we had static and moving, that went okay. For me in my class, they did real well in the fluid.
oh,
When
so
when we extended it after the video
to the next part.
to the fluid friction.
And like you guys did asked them to add an example of a friction in a fluid after seeing the shuttle burning up,
Yeah.
and I did it before, and I felt I had to be really explicit because we haven't defined fluid as being a gas as well or something that flows. So I had to say, tell me a time when something slows down because it's moving through air or through water, and then they were able to come up with examples, sort of talking to each other.
I thought that some of the work that I had done when we were back in chapter 13 with balanced and unbalanced forces, because we had talked about spacecraft a little bit, and we had talked about air resistance and coming from space into the atmosphere. So I think that that part of the video is easier for them to understand, only because they had some previous knowledge
Right.
about it.
And since we weren't there yet, and our
And you
kids,
weren't there, I was a little ahead of you.
yes, so our kids, that's the difference. They didn't have that previous knowledge. So, and then so the video of the shuttle burning up, it was very short, but I think it was really significant.
Yeah, I turned off the audio and they asked the kids, like, why is this shuttle burning up? What's causing it to burn up? And that's when they realized, oh, must be friction's causing it to burn up.
Right.
So then we were able to apply it to, not air resistance, we didn't know that yet, but.
This is totally off a little bit, but even today we've moved on and we're in chapter 13, so we're doing gravity and forces, and we were talking about acceleration due to gravity. And once they have the calculations, like, okay, so this is how much things speed up when they fall. And a girl kind of went, yeah, except, but if it was heavier, right? And I said, well, let's find out. So we pick up a Clorox wipes container and a paper. And I hold them, I climb up and I hold them as high as I can, and they both shoot to the floor simultaneously. And the whole class kind of went,
Right.
And then one kid goes, yeah, but turn it the other way.
The paper, yeah.
And I go, okay, why? And he's like, well, because this edge's sharp. And
So he said?
Yeah, this edge is sharp, and this edge is not. And I said, well, okay, do you have other, and one kid goes, friction. And I'm like, oh, okay,
Right.
so it went in. So it was good.
It's funny.
Yeah, that's very powerful in my class too, because I get up with a really light ball and a really heavy ball, and we drop them off. I can get up to the ceiling and we drop it on.
Oh yeah, it surprises them. So then the lecture comes next, and I mean, what's nice about this is that it's pretty concise, super short. But I think it was important because when we get to the performance task, most of the kids referred to that as a reference and as a source.
Yeah, because it's very straightforward.
I'm pretty sure pretty much all of my kids refer back to it at some point or another as one of the resources.
Right, and they referred back to it accurately and in the right way. So I feel like that forced them to go back and process through those, which was really good. How did the lab go for you guys?
I thought it went great. First of all, I pre-corrected for some of the little foibles that we encounter last year, where kids don't understand that that's vinyl on one side of the block, or they can't find the cardboard. Like I couldn't find it when you were showing me how to do it. So to pre-correct for that up front made it go faster. And I think that the the basic science behind the lab is easy for them to grasp at
Right.
that point in the lesson.
Right. And I think when I showed you, I don't, for me, those spring scales don't work very well.
Your idea of bifurcating the table, it was a good idea.
Well, I think it introduced a couple things. So, one, the distance isn't very long that they get to drag these things.
Yes, it's hard to see.
So by the time you even get it going, you're off the edge, and then it's bouncing.
Yeah.
And so, so I have them. We'll try to get the number, but then next to it, qualitatively say rank them. Which one felt the hardest? And I think it's good to talk about quantitative versus qualitative.
We did.
Which is a
Yeah.
nice place to like.
Because they don't really match up in this lab.
No, they don't.
Yeah.
And I kind of told them it's hard to get consistent data here. So use your qualitative data as sort of the tiebreaker. When you can't tell the difference, you could tell by feeling it and by looking which one had more resistance or more friction, and so use that. So that was a good part of that conversation.
And that paced it through quickly because they didn't get stuck and then stop and
Right.
lose momentum.
Exactly.
Also think that was one of the better ones that they used a lot as well inside the performance task. They kept referring back to that one because the
Agreed.
two that had the most amount of friction, that was the most common source,
And
most
that was-
common.
So we were to our performance test. So we had them write, generalize. Why was our first attempt not good? And I think it is because we didn't ask, they only had to describe something.
Mhm.
They didn't have to solve a problem.
Number one, and number two, for my groups, as we just begin to outline the framework for making scientific arguments, as we just begin to outline claim, evidence, reason, we just have to stay on it.
Mm-hmm.
They fall out of making explanations, and all they want to do is make descriptions of things. And so we have to keep, right now in the honors classes, it's what's the explanation, what's the evidence, what's the evidence, what's the evidence. So that was what was light on mine.
I agree.
Yeah.
And if you only have to describe something, you can get away with your evidence being light. But I think if you have to solve a problem, if you have to fix something,
Right, that's way different.
yeah.
And the prompt limits to what, like you say, what happens if there's no friction? It limits the amount of answers you could possibly have. So
That's
you end
true.
up having the same answer over and over on every single situation.
It didn't matter how the situation changed. They came up with the same explanation.
Yeah, so it's very limiting.
Okay, so we agreed we didn't want to do it again, and then it's what do we do next?
Right.
And so I think the shipping and sliding one, the Connecticut state prompt, gave us a lot to work with.
Mhm.
And so now finally they had to do something where there's a problem
Right.
and you need to solve it and you need to get the crates to stop sliding. And I like that it also said, and not just stop sliding, you need to get the crates to stop sliding by reducing the friction.
Yeah.
Right.
So that they didn't go off and go the wrong way and, go off the wrong way and not talk about friction.
Yeah.
And I think you had somebody who wanted to glue it down.
Yeah, I had a few kids
Yeah,
where
you
they
had
missed
those.
that part, even though I mentioned it numerous times. Make sure you focus on friction. This is about friction. Focus on friction. I still had a kid say, glue the crates down, nail the crates down, and the last one was use magnets.
Well,
Don't know
if
how
they
that
put down an adhesive and you tried to push on it, it wouldn't go. Would you? Wouldn't you say there's a static friction
argument to be
component?
made. Yeah,
I
absolutely.
was wondering about that. That's also chemical. I mean, it might be some
Electromagnetic.
chemical stuff.
Yeah.
Too, so.
But yeah, I had kids who started to almost kind of go the wrong way. But if they used a solution that I felt wasn't about friction, but then in their evidence they went down and said, like for example, one girl said like push down on it, and then she said, well, and she referred back to evidence and said, well, when we push harder on something, friction increases.
I got that one too.
Like if
It
you rub
increases
lightly,
the mass. That's
right? Like,
Yeah.
but if you increase the force, you increase the friction.
They
And
said
so
put more weight in it.
right.
Right.
And so I was kind of like, well, you're referring to the evidence and supporting what you said, and you're referring to the evidence accurately.
Mhm.
So that should
so
count.
that will work.
Yeah, but these were just
You said
so.
you had somebody with tying knots too, and referring
Oh,
that to be friction.
So
as
at
well.
first, one girl said, and she drew a picture. She said, you pile them in the center of the cargo room. You hook a chain to them, tie a knot, and then hook it to the wall, and it went off in 4 directions.
And so it can't go anywhere.
And I was like, okay, well, all right. And then she said, because according to the Bill Nye video, friction is what keeps knots tied. because when you increase the tension and
She remembers that from Bill Nye.
and I said, you
Yeah.
got it. Like, okay, I didn't think you were going the right way with that.
Stretching it,
But
fair.
you still refer to friction being the ultimate force that was solving the problem.
Mhm.
And so I thought that that was really good. But I would absolutely do the second one again.
Yeah.
And when we did it, the students took it very seriously.
Agreed.
Did
Mhm.
they?
It
I
was-
was a little, I thought,
It was silent.
yes, it was silent.
And I think SBAC testing and having sat in these situations where when they're doing a performance task, it's a very serious situation, carried over into class.
Mhm.
So you hand them a performance task and they ultimately go into test mode, I think.
Well, and we've been talking a lot in our sections about this is the kind of work you will do in college and in your career, where you get together with either with people or sometimes by yourself, and you have to solve a problem that's put out before you. And so the fact that they had a problem, there was a little bit of a narrative, they could place themselves in the situation, and it was almost like the narrative in a video game, sort of,
Mm-hmm.
that I was amazed that there was so much engagement in it.
Agreed. I'm so glad we did the first one and it didn't go well.
Yeah.
And that we had the chance to fix it, because this is so much better.
Because they don't really compare.
And as far as the grading scale that we made, I know that on the SBAC grading rubric, evidence and explanation is a 4-point scale.
Mm-hmm.
But I think because this is a scientific, because this is science and we rely.
This is our framework
Right.
for solving things.
Exactly. So I think the 6 points was fair there.
Yeah, I agree.
Purpose and organization 4, that's the same as SBAC. Conventions 2, that's the same. And then I think adding the statement of the problem, the clear solution, and the reason were important because we specifically asked them to do that.
Yeah.
Did you have? I liked this grading
Yes.
scale.
It also links back to claim evidence reason.
As I was grading, I didn't find anything that I caught that couldn't be reflected there.
Yeah.
Right.
I agree.
So
Right. Everything could be shown in the rubric as what was done, and also it gave the students a guidepost to make sure that you hit these points.
Agreed.
That this is a certain kind of writing. It's a certain framework for thinking, and you got to know this. There's a way to do it and a way not to do it.
The only, I would say, if there wasn't a consistent error in the kids' writing, the only consistent error I would see is they would say, this is the problem, this is what I think you should do, and here's my evidence. And then the evidence was not related to their claim.
Right. And
So
we
then
found that out
they
before,
have to
haven't we?
Yes.
Yes.
So all of a sudden they went, okay, so, fill the cargo room with crates so that they're packed in so tightly nothing can move. And I'm thinking, okay, that's not increasing friction, but yeah, that would work.
Yeah.
Okay, and then they would go down here and give 3 examples of what friction is and how to increase it or change it.
And that wouldn't have anything to do with
it did not have anything to
loading
do
up
with that.
crates.
The only thing I found in the evidence that came across a problem occasionally was some kids would say about how can you reduce friction, or other evidence that weren't related to how to increase friction, like change it to rolling friction. Like that's not related.
Right.
Exactly. So
they
they just
went the opposite way.
they could one. I think my favorite, and I only got this once, was increase friction by reducing lubrication. So a girl said, basically, clean the floor. Maybe there's oil left behind on the floor. And I thought, ooh, that's kind
That's
of like
pretty good.
second step. Like, not just increase friction by adding something, increase friction by reducing a lubricant. I was like, yeah.
As long as we have to make sure on the performance tasks that they stay within the constraints. That's part of, you're right. So like
our constraints or
our constraints. So
Okay.
for instance, the chain's okay, the cleaning the floor's okay, nailing it to the floor is not okay.
right.
We can extrapolate out to a friction argument eventually, but that's really stretching it.
Well, and I feel like that responsibility falls on us to explicitly say your claim needs to the solution needs to be because of increasing friction.
I think part of what also makes it a little better is when we ask for the claim to say, give 2 ways, like not 2 ways, but I want to hear 2 things. Like, okay, we'll put the crates and sandpaper and the carpet on the ground rather than just put carpet on the ground. I want to hear 2 things. That way they have a couple things to talk about in their explanations.
That is good. I had a couple of kids who did that.
So tell me 2 ways.
Yeah, somebody even had like, okay,
And then
weighing
you got-
down sandpaper on the crates, carpet down. And it's like, okay, well, now they're being very creative and they're really thinking about good ways to keep it from moving.
And it's going to be easier to come up with evidence.
Yeah, and they did.
You don't have to come up with 3 pieces of evidence for the same thing.
Exactly. That's
That's
why
a
I
good
think we need
point.
to
That's
modify
true,
that.
yeah.
Okay.
Yeah, that's right.
We could do that.
Well, they're doing it already. They
Yeah.
kind of did.
Well, and this was just so much easier. On the previous one, when they struggled to come up with evidence and I had to create a whole scaffolded structure, they knew what to do here.
Mhm.
So we need to repeat this sort of structure.
This is I think is going to work well, and I like the idea that we started out with, which is basically a warm up, and we
Yeah.
always do warm up, so nobody
Yeah.
really knows what's going on.
Mhm.
And we have the whiteboards, and we have a Keeley. We did at least have a Keeley writing sample. Then we have the lab. Then we have notes, and by the time we're done, we've pretty much hit friction as a force
Right.
from about 6 different
Right.
angles.
Now we just need to be able to do this with everything.
Yeah.
Eventually.
Now the purpose is to repeat this with other topics, right?
Totally. You could also tie in a couple different topics into one performance task too.
Thank you
That's true.
for like a summative kind of
Mhm.
That's
situation.
a really good idea.
Think of 12, 13, 14
Performance
as
task.
one
A physics
performance
performance
task.
task.
Yeah, it doesn't have to be specifically.
that could be
friction.
multi-layered. Yeah.
Well,
Yeah.
and you could do something like this at the end of each chapter that's a really very specific, and then something much more broad and maybe more involved at the end of all of physics.
Yeah.
Right. And that neatly wraps it up.
Mm-hmm.
You can take that little box and set it here and move on to astronomy and open that box as you need it.
Yeah. All right. Yeah. Yes.